So, Math AI HL review of vectors. Concept of scalar vectors, okay, that's fine. Represent vectors at directly lines again, that's no problem. Unit vectors. Now, I is a unit vector along the x-axis, j is along the y-axis, k is along the z-axis. So, components of vectors, whenever you want to represent vectors, we have v is equal to v1, v2, v3. We write as a column vector, which is same as v1i plus v2j plus v3k. The zero vector is 0, the vector minus v is oppositely directed. Now sum and geometrical approaches to calculate the sum or difference of two vectors. So this is also required. So when you're finding sum of two vectors, if they ask you to find it geometrically, if you have one vector and the other vector, if we have one vector and the other vector, correct? So if this is vector A and this is vector B, you can use the parallelogram law of addition to find out your A plus B. Yes. So this vector would be your A plus B. And if you want to find out vector A minus B, what will you do? It will be the other way. So what you do is your this is your A, and your minus B, minus will be going in the opposite direction. So this is your minus B. So this is a minus B, and this vector would be your A minus B. So basically A minus B will be the other diagonal in the parallelogram. Yeah. Correct? Important. Okay, in a parallelogram, so if I erase this out, in a parallelogram, your 1 is your A plus B, and this one is your A minus B. This is something you need to remember. Okay. Now calculate the sum and difference of vectors, geometric and algebraic. It's algebraic that we just add the components and subtract the components. Multiplication by scalar parallel vectors. So when two vectors are parallel, your vector A is equal to KB. Means your vector A will be some scalar times B. So it will be either be 2B, it can be half B, doesn't matter, any scalar. So this is the condition for parallel vectors. So you must remember this condition for parallel vectors. Magnitude of a vector. So if you're finding the magnitude of a vector, it's simply root of v1 square plus v2 square plus v3 square. Magnitude refers to the length of the vector. Yes. Correct? The sum of two or more vectors. So you basically just add them. So component wise, this is not a problem at all. Position vector. Now, position vector, generally we express vector with respect to some origin, okay, and that we call it the position vector. So if you have a coordinate system and if you have a point A, then your vector OA is called the position vector. So you join the point to the origin and that vector is called the position vector. We generally name it as small a. Okay. Now, if you have 2 points, PQ. So if you want to find out vector PQ, origin is not involved over here. But your vector PQ will be OQ minus OP. Remember the position vector of the second point minus this position vector of the first point. Now that's very important. Huh? Because that will keep on repeating again and again.
How do you find OQ and OP?
So they'll give you, like suppose if they give you that position vector of Q is, let's say, minus 1, 2, 3. And position vector of P is given to be 0, 1, 1. Okay. Find PQ. Okay. So they'll give you that. Okay. So you do position vector of Q minus position vector of P. So they have to give you some related information to find. Okay. Rescaling and normalizing vectors. Now rescaling and normalizing vectors is a unit normal vector is vector upon the magnitude. Yes. So if you have a vector, let's say any vector, let's say A, a unit vector is length 1 unit in the direction of A. Now to find a unit vector, you do the vector upon its magnitude. So you do vector V upon its magnitude. So for example, now that's your normalizing vectors, means you're getting the unit vector. Now they're saying rescaling. Now rescaling is this example. Find the velocity of a particle with speed 7 meter per second and the direction of this vector. Now this is a very important thing. So velocity, when you're finding velocity vector, is equal to speed into the unit direction vector. So you know the speed. Speed is 7 meter per second. Now to find a unit vector, you do the vector divide by its magnitude. So this will be basically 7 over 5 root of 3n plus 4u. So that's your velocity vector. Huh? So when you multiply your speed by the unit direction vector, now this is very important. This they keep on asking. So velocity vector speed into unit direction vector. That's the meaning of rescaling. Acha, you should also know. Okay, that will come automatically now. Vector equation of a line in the 2 dimension and 3 dimensions. So to find a vector equation of a line, this is the formula that we use. Your r is position vector of any point. So basically r is x, y, z. Your a is a known point. Okay. So whose coordinates are known. So let's say -1, 2, 3. This will be given to you. And your b, lambda is your parameter, and b is the direction vector. B is your direction vector. Direction vector is a vector along the line. Okay. So if I give you, find a vector equation of a line joining AB, and the coordinates of A are given. I'm just giving you some random numbers. -1, 3, and let's say -1. So how to find a vector equation of line AB?
So you have 1 point already.
1 point we already have. Direction vector, how will you find out? Direction vector. Yes, direction vector is any vector along the line. So you can find out AB or you can find out BA, it won't matter. So if I find out AB, so B minus A. Correct? So that's -2, 1, -8. That's your direction vector. So your vector equation of a line will be R is equal to A plus lambda times B. You can also use point P. Okay. Point B, I mean, sorry. And instead of direction vector, you can also use BA. It won't matter. So there will be a number of possible answers. Yeah. Now, what is the parameter? Every point on a line will have a corresponding parameter. Yeah. So generally the point which is given over there, so suppose if I've chosen point A, your parameter will be 0 over here. Yes. And as you go ahead, lambda is 1, lambda is 2, lambda is 3, lambda is 4. Lambda can also be fraction. Yeah. Integer makes it easier to understand. Yes. Okay, so that's your parameter, which is very important. So that is useful to find out, if you want to find out the midpoint, you want a certain ratio, then if you want ratio 1:2, yeah. So if you have your lambda is 1, then you take lambda accordingly in the same ratio, you get the points. There's some examples that we will be doing. Converting into parametric form, you just split the components. So basically, if you have to write this in parametric form, yeah, correct. Now this is also very important for assuming any point on the line. So if I say, if this is your line L, if this is your line L, your AB is line L passes through AB. Assume any random point. You can assume as x, y, z. Yeah. But the problem with assuming x, y, z is you are getting 3 variables. Okay. Yeah. So it's easier if you assume let the point be 1 minus 2 lambda, 2 plus lambda, 3 minus 8 lambda. So if you know the equation of a line, you assume any general point using this method. Means what is happening? Out of 3 variables, you are left with only 1 variable. So instead of assuming it x, y, z, yeah, you write in terms of lambda, means you are only solving for lambda. Okay. They will give you some condition, equidistant, perpendicular, yeah, something will be there. Okay. But remember that, so this is especially important for assuming a point on the line.
Assuming like
means you have to, they'll say, okay, find a point on the line which is equidistant from, let's say, P and Q, some P and Q coordinates. So rather than assuming x, y, z, you assume in terms of lambda.
Is it equidistant? How do you assume?
So PA is equal to PB. Yeah. Distance formula for PA, yeah, you'll get an equation. Okay. Distance formula for PB.
But A is just a point in between the two.
No, A is any point whose coordinates will be any random point.
So but you have to find the point as equidistant, right?
So that you are on the line.
So but what would you assume the
point A will be given, point B will be given.
Yeah, so you just take the midpoint of those two.
No, not necessary. Equidistant doesn't mean midpoint.
So we don't want
Good, I said that. Equidistant does not mean midpoint. So equidistant means what you have. You will be given some 2 points. They'll give you some equation of a line, and they say find a point which is equidistant. So yeah, this is, let's say this is A and this is B. A ka coordinates are given, B ka coordinates are given, and the equation of this is given. So you assume this in terms of parameter, and then you say, okay, this distance is
But how do you assume it in terms of the parameter?
like this. I told you, no, 1 minus 2 lambda, 2 plus lambda, 3 minus. So let the point be this.
Oh, okay. So and then what did you do with these points?
Right?
So I'll give you an integration of that to the distance.
Suppose this is 1, 1, 1, 1, 7. Your P is what? 1 minus 2 lambda, 2 plus lambda.
Oh, so then you do AP equal P.
Ah.
Okay.
Well, you're solving only for lambda. You're not solving for x, y, z.
Yeah.
My whole idea is when you assume and with the parametric form, it makes it much easier. You're working for one variable. Vector application to kinematics, finding positions, intersections. So basically, kinematics again, your position at any point and any time t, or you can call it, your textbook and call it r is equal to r0 plus tv. So r is position at any time. Your r0 is the initial position. Your r0 is the initial position, which will be given to you. A velocity vector will be given. And your time behaves as a parameter. So this will help you to find out the position. R is the position at any
They
time.
give you R also.
Then you're framing an equation. See the
Okay,
example.
so
Ah,
those three parameters.
yeah, you're getting an equation. Intersection. How do you find the intersection of two lines? You equate them and solve for the parameter.
So but you have to know in terms of x1, x2, x.
So if you go through what we have done, so if you go through this, there's a cross product. This is much later. Earlier parts if you go through. Midpoint, okay, this is quite easy. Magnitude, correct? Smallest possible magnitude is you find a magnitude, GD sketch and minimum level. Vector equation of a line, this is your direction vector. You do the subtraction, correct?
Yeah.
That will be the direction vector. You put your point and your line. This is the equation. This is fine. Here. Show that these two lines intersect and find the coordinates of the intersection. So you've been given two equations. So they might give you two positions.
Yes.
Then if your kinematics are there.
Yes.
Okay, do the paths cross.
Okay.
So you equate them. You write this in parametric form. Equate the x's, equate the y's, equate the z's.
Okay. And then
Take any two equations, solve them simultaneously. You'll get your lambda and mu. This should satisfy the third equation.
okay.
Only if this happens, then the lines are intersecting. Otherwise, the lines are skew lines. They are not intersecting. Now, to find out the point coordinates of the point of intersection, you substitute these. You substitute. If it's lambda, put it back in this.
Okay.
So you'll get your x, y, z. So that's your point of intersection. So if they ask you coordinates,
So you
you have,
substitute in the other.
or you put a mu in the other one. No need of doing both.
Understood.
How do you find the angle between two lines? That will come further down. That will also come further. Whether or not the lines intersect or not, again,
Same.
you find lambda and mu. Now see here, you will find that they are not equal. You solve the first and second and substitute in the third. So these two you are solving and substitute in the third. Now the lines are not intersecting over here. Yeah, this is what I was saying. So you are using the parameter over here. Show that the AB lies on this line. Correct? So you can substitute and you'll get the same value you can substitute this, get the value of t. So as t is consistent, the point lies on the line. Here also t is consistent, whether you put x, y or z, your t is coming the same, so that's your point B. So both of them lie on the line. Then they're saying find the coordinates of point C. You have to find the coordinates of point C so that AB is equal to BC. Now here we got t is equal to 0.
Yeah.
And here we got t is equal to minus 2. So what will this be?
T is equal to 2.
2. So you take t is equal to 2, put it in the equation, put t is equal to 2 in the equation, and you'll get your coordinates of point C. So they can give you any ratios, okay? Find a point D so that this ratio is 1:2.
Okay.
So you take t is equal to 4.
Yeah.
So that's the use of the parameter. So parameter means every coordinate x, y, z corresponds to a parameter. So t is equal to corresponds to this on the line. T is equal to minus 2 corresponds to this point on the line. That's the concept of parameter. How do you find a point of intersection of two lines? Again, the same things. First, you construct the equation, then you solve those to satisfy the third one. How do you find where it intersects the y-axis?
You
You have to put z and x as 0.
okay.
Because they're intersecting only the y-axis. So the other two coordinates will be 0. And so on. Acha, how do you show that it doesn't intersect the it does not intersect the z-axis? So if you put your this and this as 0, you will get different values of lambda. See here when you put your x as 0, z as 0, you will get the same value of lambda. And then you put this lambda in the y coordinate, you will get the y coordinate.
Okay.
But if you don't get the same parameter, means these two lines are not intersecting.
Yeah.
That's
I don't know what to do.
further. Full vectors are revising.
Yes.
Find P. Find the value of P for lines this and this if they intersect. So you basically write in the vector form. Yeah. You equate and you solve basically. I mean that this is quite easy. Now this is very important. Whenever the distance of a point is asked, it is implied that the perpendicular distance is best done by using scalar product. This is one question that we left, and this is very, very important. Find the distance of a line with this equation from the origin. So let's draw a schematic diagram. You have some line in space, correct?
Yes.
Let's call this L1. So this is my line L1. And you have origin. What is the distance? Now the distance between the point and the line is always the perpendicular distance. That's your shortest distance. And the shortest distance is the perpendicular distance. You have to find this distance. So let's call this point P. Let's call this point N. And this is your line.
Yes.
Step 1. Your point P we know. 0, 0, 0. Origin is 0, 0, 0. Step 2. How will you assume your point N? I told you, use assume as parameter. So minus 2 plus 2 lambda x, y, and your z.
So and then scalar product will be dot product will be 0.
Dot product. So now one second. Yeah, that's correct. Very good. You get your P. Now get your vector Pn. Or anything. It won't matter. So Pn will be what? On minus vector 0, 0, 0 origin. Correct? So that's my vector Pn. The next thing you'll do is you'll take the dot product with the direction vector. Pn dot the direction vector will be 0.
Pn dot the direction.
The vector of the line. So what's your Pn? 1 plus 2 lambda. Correct? Minus 2 plus 2 lambda. 2 plus lambda. Dot. What's my direction vector of the line? 2 to 1 is equal to 0. So this will become mu multiplied.
So why do you wonder that? But why is it like dot into the direction?
What is the reason for two vectors to be perpendicular? Their dot product should be 0. So if two vectors are perpendicular, then your dot product is 0. This is the condition for perpendicular. So that means if I want the shortest distance is a perpendicular distance.
Yeah.
We are assuming the coordinates of n.
Yeah.
We are constructing vector n Pn. We are constructing vector this. That's our direction vector.
Yes.
We are finding position of point n. Where should point n be on the line? So that this is perpendicular. Because if I take it anywhere, this is all about distance.
Yes.
Distance is perpendicular distance.
So this is just straight multiply the 2 plus 4.
2, 1 plus, x1, x2, correct? Plus y1, y2. You remember this, no?
Yes.
Because obviously this is a revision video, so I may not go into it. Solve for this. So 2 plus 4 lambda minus 4 plus 4 lambda, correct? Plus 2 plus lambda. So that's how much? 9 lambda.
No, so it's 2 minus 4 is minus 2 plus 2.
This is 9 lambda.
9 lambda equals
9 lambda is equal to 0. Correct? This is yeah. So lambda is equal to what? 0. Now what do you do with the lambda is equal to 0? You put it in n.
you find P in P.
Or you can find Pn. Put in Pn. So that will give you a vector Pn. That will be if you put lambda 0.
1 minus 2, 2.
Now you find the magnitude of this. That will be your distance. So a square plus b square plus c square, or x square plus y square plus z square. So root 9. What is that? So the shortest distance is 3.
So when do you use dot product? When do you use scalar?
So dot product is also called the scalar product. So we are coming to that. That will come in this. That will come in this automatically. So kinematics, we did this velocity vector speed into unit direction vector. We also did this position at any time t is the initial position plus tv, where v is the velocity vector.
Yes.
The other important thing is bearing.
So what I
Now,
do is
to find a bearing from a vector, the bearing is always the angle with respect to the north.
Yes.
Correct? So I'm just showing you one example. So v is equal to 5, 4.
Oh, this is
So you draw your 5, 4 and try to get this angle basically. So then you use your trig and get that. Correct? Similarly, if you have anything like this, you see variable vector. So your bearing would be this way. So you basically do SOCART over, get this angle, SOCART using
so that would be
SOCART.
3D first.
Sorry? No, bearing won't be in 3D. Bearing will always be in 2D. And you do this way.
Yes.
so
So that's how you get bearing. So this is how you find the bearing from that. Direction vector speed, this we did. Correct? Velocity speed into unit direction vector. This is nothing that easy. This is all easy. Please make it a point that you go through this important question,
Yes.
which involve bearing and all that. I'm going through only the concepts which are there. Now the position vector of two drones have been given, show that the vector drones will collide.
So that means the paths will cross.
The paths will cross, and also at the same time they'll be at the same position.
So first you have to check if the paths cross.
Paths cross, and also if the parameters are the same, t1 and t2, basically, if you put it back, you should, for the same time, you should get the same position. Go through it, it's easy. But when you start solving it, you have to call it t1 and t2. Now we'll come to the scalar product. Your a dot b is called the scalar product. The most use of the scalar product is in physics. Force dot displacement is the work done. So that's your magnitude of A, magnitude of B into cos of the angle between them. If you know the components of vector A and B, then your A dot B is equal to A1 B1 plus A2 B2 plus A3 B3. This is used to find the angle between two vectors.
Okay.
So obviously you make cos theta the subject. So whenever you find angle between two vectors, you have to think of this formula.
Okay.
Cos theta is equal to A dot B upon magnitude of A, magnitude of B. That gives you the angle between two vectors. If two vectors are perpendicular, dot product is 0. Very important rule that we used already. Component of A acting along B in the direction of B is A dot B upon magnitude of B.
So this is going A dot B and A multiplied by
A dot B is your dot product, where we use the cos theta as the formula.
B. Okay.
A cross B is your cross product, where you use your sin theta as the formula.
So this is just dot product.
This is just dot product I'm talking about. Dot means dot. It's not like your multiplication of numbers where your dot and cross means the same thing. Your dot means something else, cross means something else. Dot means this is the method you use, cross means you have to, I'll be showing you what method to use. If it's perpendicular, then you have to use the magnitude of A cross B upon B. So we'll be seeing that also. So dot product, this is one example I've given.
Okay,
Next,
there is no line.
May 23.
This is also easy.
Oh.
Straight up.
Yeah, this is. So this is all easy. How to find any angle? Find angle BAC.
So I find AB. I find AB.
Now always vectors should be directed outside. AB, AC. Find those vectors and then you use the cos theta formula. Perpendicular dot product is 0. Okay. Angle between two vector lines is the angle between the direction vectors. Don't forget that. So point of intersection, you equate them.
Okay.
For point of intersection, you equate them.
Yes.
And for angle between two lines, you use the direction vectors and use the cos theta formula.
Okay.
Cross product. Your magnitude of A cross B, mind you,
Yes.
is a magnitude of A, magnitude of B into sine of the angle between them. Now this is a definition. You can't challenge this.
Yes.
A cross B, if you want to find it manually, you put A1, B1, C1, A2, B2, C2. Then what you have to do is you have to do B1, C2 minus C1, B2.
So can I just do it on a calculator?
You can do it on calculator, but if the variables are given, you need to know this mechanism. But this is then your formula booklet as well. Minus A1, C2, C1, A2. But the minus of this. There's a formula. Okay, and the third one when you're getting A1, B2 minus A2, B1. Basically, this gives you a vector. So if A is a vector and B is a vector, both lying in one plane, this is the plane. Then your A cross B is the third vector which is perpendicular to both these vectors. This is perpendicular to A also and perpendicular to B also. Very important. Sometimes they'll give you two vectors. Okay, find a third vector perpendicular to both. So you just find a cross product. That's it. They won't tell you find a cross product. They'll say find a third vector perpendicular to both. Area of a parallelogram is equal to BA. Find out vector BA. Find out vector BC. Take the cross product using this method. And once you get the cross product, find the magnitude. So find the magnitude of this. Area of a parallelogram is find out BA, find out BC, get the cross product, get the magnitude. Area of triangle is half the area of the parallelogram basically. So you follow the same method. But don't forget that your vectors have to be directed outside. Find out vector BA, find out vector BC if not given, if they give you coordinates. Then you do this method. Now this is what I just showed you. This is then your formula booklet, third vector. So this conceptually this is there. And then you to just keep on applying. You just keep on applying. This is also important sum. Make it a point that you go through this. It's an important sum. It's based on all the concepts that we did. So make it a point that you go through all these important sums that I have. 3 dimensional also.